Hello, how are you? How are we doing? Hope you are doing great today. I'm doing great. Hope you are doing great too. And I'm back again. We are talking about representing, charting numerical data, quantitative data, such as people's age, income, height. How do I represent those information by graphs and charts? That's what we are talking about today. So we will continue on our discussion and we are going to discuss some new things today. So I hope you're all set, all excited along with me to learn more about these new ways of representing quantitative data, and request you to stick around till the end of the video. I'll give you some important hints or tips at the end of this program. So let's get started, and please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to click on the notify bell button. So here I go. I'll share my screen with you. So first we talk about Chebyshev's rule. One thing we have to remember, very important thing to remember, Chebyshev rule applies to any kind of probability distribution. It does not have to be bell-shaped. It can be, for example, an uniform distribution, which is a rectangle basically. So Chebyshev's rule applies to any kind of distribution. Where people get confused is this 1 minus 1 over k square. What does k mean? K is number of times of standard deviation. Okay, so k in Chebyshev starts from k equal to 2. Now what is k square? 2 square is 4. So 1 minus 1/4. From $1, you take a $1/4 away, 1 minus 1/4, you are left with 3/4 of the dollar, or 75%. Okay, so what is Chebyshev's rule saying? Remember, at the center, you have the mean. If you go from the center, two standard deviations on the left and two standard deviations on the right, this is the center, the mean. You went two standard deviation, means 2 times standard deviation on the left of the mean. So you reached a number which is 2 standard deviation below the mean on the left. Similarly, you can add 2 standard deviation, 2 times standard deviation to the mean, and reach a number which is 2 times standard deviation above the mean. You draw two vertical lines. What is Chebyshev is saying, for k equal to 2, that is, you went 2 standard deviation on the right of the mean and 2 standard deviation on the left of the mean, at least 3/4 or 75% of the data will fall. So you want to get an idea how much, what percentage of the entire data will fall within certain boundaries, and the boundaries are established by plugging in k value. And Chebyshev starts from k equal to 2. That means 2 standard deviations on the right of the mean and 2 standard deviation on the left of the mean, at least 75% of the data. Okay, people get confused. They do not understand what is k. K means how many standard deviation you're above the mean on the left and how many standard deviation you are below the mean on the left. You draw two vertical lines. You reach the top of the probability distribution, you will cover at least 75. At least means the lowest percentage of the data between two standard deviation on the left and two standard deviation on the right will be 75%. The lowest, it can be greater than 75%. So here is a stem and leaf display. Okay. And the mean works out to 190. Standard deviation is 7. 2 times standard deviation is 14. So the mean is 190. To this you add 2 times standard deviation, 2 times 14 is 28. Or sorry, 2 times standard deviation is 14. 190 plus 14 is 204. And 190 minus 14 is 176. What do these two boundaries mean? You draw two vertical lines at 176 and 204, reach the top of the probability distribution. You are going to cover at least 75%. At least the lowest is 75%. In reality, in this data set, 97% of the data fall between 176 and 204. So Chebyshev is covering the ground. If you go three standard deviation on the left of the mean, and on the right of the mean, draw two vertical lines. Chebyshev says at least 18. 89% is the minimum area between, or minimum percentage of data between those two. Actual data is 100%. So that's what Chebyshev. Important thing to remember, Chebyshev applies to any kind of probability distribution. It does not have to be bell-shaped. Okay. When the probability distribution is bell-shaped, we apply the empirical rule, and the at least term is replaced by approximately. And for bell-shaped distribution or normal distribution, bell-shaped is an inverted U. If you go one standard deviation on the right of the mean and one standard deviation on the left of the mean, approximately, no longer at least, approximately, you have nailed the number down. Approximately 68% of the data will fall within one standard deviation of the mean. And if you go two standard deviation, it is approximately 95% of the data. And if you go three standard deviation on the right of the mean, three standard deviation on the left of the mean, it is approximately 99.7%. That is almost the entire data is within three standard deviation on the left of the mean and three standard deviation on the right of the mean. Now, three standard deviation means you multiply 3 with the standard deviation, get a figure, then add that 3 standard deviation to the mean to establish the right boundary, and subtract the 3 standard deviation from the mean to establish the left boundary. Draw two vertical lines to meet the probability distribution, the bell-shaped, and it is approximately 3 standard deviation is 99.7%. I'll tell you a hint. Empirical rule is also known as 68 for one standard deviation, 95 for two standard deviation, and 99.7 for three standard deviation. Okay. So here is the picture. The empirical rule makes approximately instead of at least statements. And it starts from k equal to 1. Remember, Chebyshev, which has the advantage, it applies not only to bell-shaped distribution, but also to rectangular distribution where the probability is uniform between the lowest number and the highest number. For example, in Chebyshev, we use the word approximately, and it starts from k equal to 2. Two standard deviation from the mean. Advantage of empirical rule, it can be applied from k equal to 1, one standard deviation away from the mean. And in empirical rule, we use the wording approximately. We no longer use at least. Okay. So here is an example. Here the sample mean is 32.9. Sample standard deviation is 4.8. Okay. Data collected suggests the reasonable values of the mean weights of the Manatee curves are. If you assume the weights of the Manatee curves are bell-shaped or normally distributed, then you add one standard deviation on the right of the mean and subtract one standard deviation on the left of mean. That is row number 1. In between these two boundaries, that is 28.1 and 37.7, approximately 68% of the data will fall. If you go two standard deviation on the left of the mean, two standard deviation on the right of the mean, establish two boundaries, draw two vertical lines, approximately 95% of the data will fall between 23.3 and 42.5. And if you go three standard deviation on the left of the mean, three standard deviation on the right of the mean, it is approximately 99.7%. So, summarizing, Chebyshev applies to any kind of probability distribution. It does not have to be bell-shaped. And it starts from k equal to 2. The wording for Chebyshev is at least 75% of the data will fall within 2 standard deviation of the mean. And at least 89%. At least means the lowest value is 89% when you have 3 standard deviation from the mean on the right and 3 standard deviation on the left. Okay. Empirical rule applies to bell-shaped distribution. It starts from k equal to 1 and approximately, we use the word approximately. We do not use the word or the term at least. We say approximately 68% of the data will fall within 1 standard deviation of the mean, provided the data is bell-shaped. And then approximately 95% will fall within 2 standard deviation of the mean, provided the data set is bell-shaped or normally distributed. So now we have established the ground rules for what percentage of the data will fall within certain standard deviation away from the mean on the right and the left. We will calculate a a standard normal score. What is the advantage of doing that? We will convert each data point to how many standard deviation it is above the mean, if it is greater than the mean on the right of the mean, or how many standard deviations below the mean. So everything, the difference between the number and the mean, that difference will be established or expressed in terms of how many standard deviation above the mean, if that normal score is positive, and if that normal score is negative, how many standard deviations below the mean. So here you go. The formula for z-score. What is z? Z is called the standard normal variable. How do you calculate z? You take a value in the population, x. From that you subtract the mean of the population, x minus mu in the numerator. That is also called deviation of the number x from the mean. Divide that by the standard deviation. Hence, because you are dividing by the normal distribution, because you are dividing by the standard deviation, the z-score is called the standard normal score. Standard because you are dividing by the standard deviation. So z-score basically tells us if the number is greater than the mean, that is the numerator is greater than 0, how many standard deviation you are above the mean. If the z-score is negative, how many standard deviation you are below the mean. Okay. So here is an interesting situation. You have accounting, mean is 56,000, standard deviation. And marketing, mean is 52,500, salary, standard deviation is 1,000. So one particular student in accounting gets 55,000, other marketing major students get 53,000. Just by looking at it, it seems like the accounting major is getting a better deal. Is he or she really getting a good deal? How do you compare between marketing and accounting majors? Well, you convert X is 55,000 for accounting to the Z score by subtracting the mean of the accounting, which is 56,000, from the number x, 55,000 minus 56,000, and divide by the standard deviation of accounting. Already you note the accounting major 55,000 salary is below the mean 56,000 for accounting. So the numerator x minus mu is negative for that case. And you are further dividing it by the standard deviation. So you'll get a negative z-score for accounting below the mean. Look at the marketing. Marketing major is making 53,000, which is slightly above the mean for marketing. 53,000 minus 52,500 is positive difference, and then you divide by the standard deviation. So the z-score for marketing major will be on the right of 0. Z-score for accounting will be on the left of 0. So looks like the accounting measure has a slightly lower z-score than the marketing measure, as you will see. So as I was saying, the accounting z-score is minus 0.67. Negative 0.67 means what? It means the score, the salary that he or she got offered, 55,000, is 0.67 standard deviation. 0.67 standard deviation, when I say, it means 0.67 multiplied by the standard deviation, below the mean of 56,000. Yes, 55,000 is lower than the mean. So we got a negative value of the z-score. Okay. And then you look at the marketing, the salary 53,000 is slightly above the mean for marketing. So it's a positive z-score of zero point 0.5. Okay. So that is much better. So when you convert everything to z-score, the marketing measure z-score is greater than the accounting measure z-score. Okay. We are also interested in percentiles. So, like a dollar has 100 cents, if you have 25 cents, a quarter of the dollar, you have the first 25% of the dollar, you do not have the top 75%. On the other hand, if you have three quarters, that is 75 cents, you have the lower 75% of the data, you do not have the top 25% of the data. So, bottom line, a percentile gives you a percent of the entire data set below that particular number. For any particular number r between 0 and 100, rth percentile is the value such that r% of the observations data set fall or below that value. You already came across a percentile. When we calculated Q1, the lower quartile, it is the 25th percentile. That means 25% below it, 75% of the data above it. When we calculate the median, it is the 50th percentile, 50% below it, 50% above it. And when we calculate Q3 or third quartile, 75% below it, 25% above it. Okay. Consider the figure which is illustrated the 90th percentile. As you can see, the shaded area is 95%, 90% of the total area. Why? Because it is the 90th percentile score. That means 90% of the scores are below that particular number on the horizontal axis. This is not a perfect bell-shaped distribution. This is slightly skewed to the right. That means more higher numbers in that data set. So it's positively skewed. Lower quartile correspond to 25th percentile, 25% of the numbers are below it. Okay. Median is the 50th percentile, Q1 is the 25th percentile, and Q3 is the 75th percentile. 75% of the numbers are below it, 25% above it. So, as I said, I'm going to give you a tip. The tip is to remember Chebyshev's theorem applies to any kind of distribution. It does not have to be a bell-shaped probability distribution. Remember, on the vertical axis, even in the figure you see on the screen over here, you have relative frequency or probability on the vertical axis, and you might have z-score on the horizontal axis. So, Chebyshev applies not only to bell-shaped distribution but to any kind of distribution, such as it can apply to uniform. What is an uniform distribution? All values from the lowest to the highest in that distribution will have the same probability, uniform probability. Chebyshev's theorem will apply there. And Chebyshev's theorem or Chebyshev's theorem, yeah, it starts from k equal to 2. That least you get two standard deviation on the right of the mean, two standard deviation on the left of the mean. The wording for Chebyshev, that is the important thing to remember, is at least. At least 75% of the data will fall within two standard deviation of the mean. 75% is the area in the probability distribution between the lower boundary and the upper boundary. The lower boundary is established by subtracting from the mean two standard deviation. The upper boundary is established by adding to the mean two times standard deviation. So at least is the wording for Chebyshev. Whereas in the same case, for empirical rule, which applies only to bell-shaped distribution like the one you see in your figure over here, it is no longer at least, it is approximately. And for two standard deviation, it is 95%. But it only applies to bell-shaped or normal distribution. And then what is the advantage of z-score? It tells you how many standard deviation you are above the mean. If your z-score is positive, if your z-score is negative, how many standard deviation you are below the mean. And why it is called standardized normal score? Because you are dividing by the standard deviation. What are you dividing by? The deviation of the number from the mean, that is x minus mean. Of course, if x is greater than the mean, then the numerator is positive, then z is positive. If x is smaller than the mean, that is on the left of the mean, the z score will be negative because x is less than the mean. So z-score gives you how many standard deviation above the mean if the z-score is positive. If the z-score is negative, how many standard deviation below the mean. Okay, so I stop here today. Any question, any suggestion, please write me a small note. Please let me know where you are watching the video from. What else you want me to cover in statistics, please let me know that. Also, please let me know where you are watching this video from. I'm really excited to be able to help you, but I would appreciate that if you please tell me where you are watching this video from. And please, if you like this video, give me a thumbs up. It really motivates me to produce more videos just for you. And if you like this video, of course, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget at that time to click on the bell button, which will notify you every time I upload a new video. Please, okay, subscribe to my channel and please do not forget to hit on the bell button, which is the notify button. And please do not forget to watch me tomorrow. I'll be back tomorrow with another interesting video. Thanks for watching. Take care. Have a nice day. See you next time.